So yesterday, okay, we went over the kind of stages that the model of the atom went through. Okay, we talked about the atomic theory, the 4 points of it. Anybody remember the 4 points? Okay, should we know the 4 points? Will they be on Tuesday's quiz? Definitely. Okay, so 4 points, quick reminder. All matter is made of atoms. Yeah, we could say indivisible particles, or we can just simplify it and say atoms. You don't have to memorize it word for word. Okay, all matter is made of atoms. Okay, okay. Second point, atoms of the same element are the same. Atoms of different elements are different. Okay. Third point, atoms can combine in simple whole number ratios to form compounds. The whole number ratios part is important. There are never fractions of an atom in a compound. Okay? And fourth point, okay, in a chemical reaction, atoms can be separated, they can be joined, they can be rearranged, but they can never be turned into atoms of another element. Okay? Those are the 4 points. Got to make sure we know those. Who came up with those 4 points? Dalton. Yeah. Okay, John. You only need to know the last name in science. Last names are what's important, but it's John Dalton, okay, who came up with that. All right? And yeah, I got to open those windows already. If you need to back up, but yes, because it gets too cold here, you go ahead. Okay. Yeah, feel free to move if you get too cold. Desk there, whatever, you go right ahead. All right. So Dalton came up with the first model. What was his model? What did he think the atom looked like? Yeah, just a solid sphere, just a ball. Okay, which at the time was fine. Nobody knew any better. Okay, and then Thomson came along. Thomson discovered what particles? Electrons. Okay, and the solid sphere model couldn't explain that. Okay, so he had to revise the model. Okay, he revised the model so that it would include electrons, which he said were like little plums that were loosely embedded in the pudding that was the rest of the atom. Okay, and then there was all this chaos with all these different models coming around. Okay, we discovered protons and neutrons, and then things kind of got kerfuffled until who came along? Rutherford. Yeah. Okay, Rutherford came along, he did his gold foil experiment, and that's what you can call it, okay? If you're ever asked about it, it's Rutherford's gold foil experiment, okay? Where he shot x-rays at that piece of gold foil, and the x-rays, a lot of them, went through it, okay? And some of them were deflected, okay? And that proved that the atom did, in fact, have a nucleus. Okay, in the nucleus would be the protons and the neutrons. It was bigger than he thought it would be. Okay, and then he came up with that crappy model that had all the electrons the same distance from the nucleus. Okay, which was then abruptly changed by Bohr, and then de Broglie. Okay, so that's where we left off, was talking about de Broglie's electron cloud model that accounts for the ability of electrons to pop up and down from different energy levels. Okay, we talked about how that drives photosynthesis yesterday. Okay, when sunlight strikes the plants, the electrons in the chlorophyll molecules get excited, they gain energy, and they jump to higher energy levels in what we call a quantum leap. When the light is gone, those electrons can fall back down. When they fall back down, they release the energy they gained from the sun. And when that energy is released, the chlorophyll and the chloroplasts can use that energy to make sugar, okay, from carbon dioxide and water. Right? It can also work for glow-in-the-dark materials. If you've ever had, like a watch or a shirt or something like that, where you go out in the light and then when you go in the dark, parts of it glow. Like, I don't know if you guys have ever seen that. It's not really a thing anymore. It used to be. Okay? But that works on the same principle. When that material is in the light, the electrons gain energy and they move to higher energy levels. When you go into the dark, the source of that energy is gone and they start falling back down to their lower energy levels. And when they do that, they give off the energy as light, and that's like glows for a short period of time. Okay? Everybody all right with that? Okay. So de Broglie's model explains those behaviors where none of the other models do. Okay? De Broglie's model allows for electrons to move and change energy. Okay? And that's why we currently accept that one. Okay? And then at the end of yesterday's class, we talked about how you would draw an electron. Okay? Or sorry, draw an electron. How you would draw an atom. Okay? And we said that you would put the protons and neutrons in the nucleus, How do we figure out how many protons there were?
Top corner.
Right, top left corner, the atomic number. That's the number of protons. It's also the number of electrons, right? Because they're always equal. Okay, and then we calculate the number of neutrons by taking this number and subtracting that number and then rounding appropriately. Okay, ringing a bell for everybody? All right. Okay, so generally, okay, we look at the model of the atom to be something like this. Okay, electrons can be in different positions in different orbits. So Rutherford wasn't like totally wrong. He was just wrong about all of them being in the same distance. Okay, the energy, the electrons that are closest to the nucleus are obviously the lowest energy. Okay, and then they can jump to those higher orbitals, okay, as they gain that energy. Okay, but in that picture, is there a lot of empty space in that atom? Okay, and that's why Rutherford's experiment worked the way it did. Okay, so if all atoms are made of the same thing, they're all made of protons, neutrons, and electrons, how is it that we have different elements if everything's made of the same stuff? The amount, yeah. Okay. When you look at the periodic table, everything has a different atomic number. Okay, has a different atomic number because every element on the periodic table has a different number of protons. Okay, it is this differing number of protons that gives the different characteristics for each element. Okay, so lithium atoms have 3 protons. Lithium is a soft, silvery metal, okay, that is highly reactive with water. Okay, if you have 8 protons, then you are oxygen. Okay, and you have you are clear, odorless gas. Okay, every element has its own properties because of the number of protons in the nucleus. So I would say that that is something pretty important from this slide. Okay. And for some reason, all of the text is shifted over. Hang on. That's better. Okay, so differing numbers. Okay, so basically all of this paragraph here is the explanation for why, okay, elements have different properties. Okay, now this picture here shows you some of what we call orbitals, some of the orbitals or areas where you are likely to find an electron. Okay, and this is only some of them. Okay, there's like literally like hundreds of them. Okay, different places, different energy levels, okay, that electrons can be found in, right? And they have all kinds of crazy shapes. Okay, one of them is even a donut, okay, that goes around. So there's all sorts of different places where these electrons can be found, and that is, again, based on their energy levels and how many electrons that particular element has. Okay? If you're looking at hydrogen, hydrogen only has 1 electron, but that electron could be in any one of the orbitals based on its energy. Okay? More than likely, it's in the nearest one. Okay? But there's chances that it could be anywhere else. Okay? That's that whole idea of quantum. Something that Marvel has done a terrible job of making everyone think that means. Okay, sort of. Okay, quantum means could be everywhere all at once. Okay, sort of. Okay, that's kind of the way Marvel explains it. But okay, in reality, it means there's a probability of it being in any one of these places. Okay, anyone need that one anymore? I see some people copying. I'll give you another minute there. in your digital workbook for chemistry, in that file that's in Google Classroom, okay, there are a bunch of questions, okay, that I would like you to answer based on the stuff we went over yesterday and for like the first 10 minutes here this morning. Okay, I want you to answer these questions because these are the kinds of things that are going to show up on your quiz. Okay, now some of it we've directly talked about and some of it we haven't, and that's okay. Okay, you can come up with your best answer and then we're going to go through the actual answers, okay, for all of these, maybe even later today. Okay, depending on how we do. All right, so I'll leave these up here. I'll scroll down in case anyone doesn't have access to their stuff. Okay, but these are I'd like you to make some complete sentence answers, okay, for these questions, either on a piece of paper or if you want to write it directly in the workbook, you can type your answers right in on the file. Okay, totally up to you. If you're looking for that file, okay, just so that you can find it here, okay, it's in the classwork tab, okay, and it's worksheet packages, okay, and you need to go to the chemistry one, okay, and just scroll down. Okay, there's the atomic theory questions. Actually, maybe I'll leave it up there because I can get more of them on the screen. I'll just make it a bit bigger. Okay, I can get 11 of them on there. I'll scroll it up in a bit.